Walter Reed National Military Medical Center is developing a pan-coronavirus vaccine. It's in the early stages of human trials. Army scientists say COVID-19, though, may not be the big one. Dr. Kayvon Modjarrad is director of the Emerging Infectious Diseases Branch at the Walter Reed Army Institute of Research. Dr. Modjarrad, welcome. It's great to have you on the program. That comment about this one not being the big one, it seems pretty big to a lot of us that have dealt with it over the last 18 months. What do you mean by that?
Well, if you look at coronaviruses as a family and look at this one in comparison to those, we had SARS-1 back in 2002. That was fortunately only in about, less than 10,000 individuals, and it had a mortality rate of about 10%. And then MERS, another coronavirus that appeared in the Middle East back in 2012, has a mortality rate of 35%. So now we have something that obviously has circulated the world and affected many people. It's become a pandemic, but its mortality rate is much lower, a fraction of what those other coronaviruses that we've seen in the past have. So there's always a potential for a coronavirus that has a higher mortality rate, and there's potential for other viruses as well that we've seen, like Ebola, for example, that can cause a lot more mortality, a lot more health problems long term than we've seen with COVID. It's not to minimize the impact, the devastating impact that COVID has had. It's just to say that there are other threats that are lurking out there that we need to be prepared for in the future.
Yes, in that context, Doctor, the intersection of virus that spreads very rapidly like COVID does and causes the higher levels of mortality in the ones that you described would be much bigger than what we're dealing with now. What are you learning, and what can you learn, and your peers in the medical community learn about from the ones that you've already dealt with that can apply to something that we don't know exactly what it may be coming down the road?
One of the things that we're trying to focus on within the U.S. Army in our vaccine program here, and had been doing prior to the pandemic, is focusing on categories or families of viruses, and trying to take information that we're learning from one virus and applying it to all its cousins, for example, in that family, and develop broader, more universal vaccines, diagnostics, and treatments for those families of viruses, so that the next cousin in that family that comes along will have something already prepared for. And so we've learned quite a bit about the structure of the viruses, the life cycle of the viruses, and our immune responses to those viruses. But we've also learned not just the science of the viruses themselves, but how our different agencies within the government, how our industry partnerships, our partnerships with academia can all come together very quickly and in a very organized way towards developing vaccines and other solutions. Really, almost, initially we called it warp speed, but it's not all that fictional to say that we went faster than we've ever gone before, and faster than we've ever even imagined that we could develop a vaccine. So those lessons as well can be taken over to the next threats.
Does this approach at looking at this cousin's perspective, Doctor, ameliorate, mitigate, or maybe even eliminate the concern that exists today about, I have the vaccine, but I don't know if it protects me from the Delta variant and all of that? Is that the hump that you're trying to get over by taking this cousin's approach, Doctor?
Yeah, it's a good point. That's the first step, is making sure we develop vaccines and treatments that are covering the closer relatives, the cousins that are much more, the first cousins, I would say, like the different variants, but also not stopping there. Taking the extra step to make sure that we develop a vaccine now that anticipates the next SARS, the next COVID. That's the general idea that we're trying to develop now.
We just have a little bit more than a minute left. What does the progression of this work look like, or is it not possible to predict that based on where the research takes you, Doctor?
I think the important thing to get across in this last minute here is that we have the tools and the technology and the knowledge base now to develop these broad platforms of vaccines and treatments for families of viruses. If you look at the big viruses that have occurred over the past 50 years or so, they've all been viruses in about 24 families. And that's it. And they've come from animal reservoirs. And so we know what's coming. And we have the technology to develop tools to anticipate what's coming. It's just a matter of investment and a focus on those particular families of viruses.
Dr. Modjarrad, congratulations on the work you're doing, and thank you very much for joining me to talk about it today. I appreciate your time, sir.
Thank you very much.